Hello and welcome, ladies and gentlemen, to the first webinar of this series about the new GOM software 2016. My name is Markus Möller. Sitting next to me are Tobias Kipper and Bernd Oerding. Tobias will show you the new functions live in the software, and Bernd will answer your questions in the Q&A section. So if you have any questions, you can ask them in the Q&A section, and Bernd will write down the answers for you. This webinar will be recorded as usual. You can therefore watch the webinar again later on or share it with your colleagues. We will show you at the end of the webinar where you will find the recordings. So today on the agenda we have some general topics about improvements for the Explorer. We will show you how you can customize your 3D toolbar. We show you some new options for the user interface regarding visually impaired people. We have some news for CAD Converter, and we will show you how you can import CT volume data. In addition, we have some new topics for GD&T, for the surface defect map, and in conjunction checks on curves. And last but not least, we have plausibility checks, which Tobias will show you in the software. So with this short introduction, I will hand over to Tobias, who will present the new functions live in the software.
Thank you, Markus, for your introduction into this webinar. I would like to start with the improvements for the Explorer. For GOM Software 2016, we improved the usability of the Explorer. You can access elements faster and more comfortable, for example, to edit elements. The usage of skins is more convenient now. And there are some further improvements, for example, the handling of stage ranges. Based on customer feedback from our forum, fairs and sale contacts, we identified some room for the improvement of the V8 SR1. By having looked at specific workflows, we now provide more information and options when working with the Explorer. For more details about the functionalities I will show you during the webinar, please use the direct help or have a look at the What's New videos. You can find the videos in our GOM service area under support.gom.com, download software, GOM Software 2016, What's New 2016. Or you can use our GOM Metrology YouTube channel. Within a short live demonstration, I will show you the new functionalities. The Explorer sorts all elements by their functionality. If you click on a category in GOM Software 2016, you can see all subcategories and elements in the Sub-Explorer under Chosen Elements. The second category, Related Elements, is a list of all elements that have a strong relationship with the chosen elements. The relationship exists, for example, if the related elements are used to construct the chosen elements. You can click on the elements without losing the information about the chosen and related elements. The same applies if you edit the creation parameters. In this way, you can comfortably work with the Sub-Explorer. You do not need to search through the Overview Explorer again and again. To look for an element, you can also use the new search function. You can see that the software directly highlights the searched word in all categories, such as nominal elements, inspection, and actual elements. The search function is not case sensitive. If you want to know more about the actual cylinder 1, for example, just select it and you can see a list of related elements in the Sub-Explorer. By deleting the searched word, the software closes all categories automatically. You can also click on an element in the 3D view. You can see that the Sub-Explorer is updated. If you want to view an element in the Explorer, you can use the new function Show in Explorer in the context menu. This function replaces the automatic expand button of the former versions. Another enhancement affects, for example, tags. Via the context menu, you can select the related elements. The related elements then become the chosen elements. This command is also available for report pages and element groups. To make the skin handling more convenient, the skin is displayed in the menu bar now. You can easily switch between the skins and manage the skins. There is a new area in the Direct Help. Here you can find more information about what's new in GOM Software 2016. In the following, we remain at the graphical user interface and we will talk about the customizable 3D toolbar. In GOM Software 2016, you can have your favorite commands fast and easily accessible. You can customize the title toolbar and the 3D toolbar. In contrast to V8 SR1, the 3D toolbar is not automatically filled with recently used selection commands. For the improvements, we tried to consider dozens of customer cases requesting customization of toolbars. By looking at general workflows, we now brought arbitrary commands much closer to the mouse. GOM Software 2016 offers new specific context menus for the element and the background. The context menu for the background reflects the customized 3D toolbar. To modify the toolbars, use drag and drop. For example, you can add new commands, move or delete existing commands. There is also a What's New video available in our GOM service area and on YouTube for more details about the functionalities I will show you. Let's have a look into the software. In the default settings, the 3D toolbar includes the standard selection tools. Now you can add your favorite commands just by drag and drop. You can move existing items via drag and drop, and you can group commands. You can delete items with the floating trash bin. All showed options are also available for the title toolbar. Via the right mouse button, you can reset the title toolbar to defaults, import or export a toolbar configuration, or edit the toolbar. In the dialog, you can switch between the title toolbar and the 3D toolbar. As always, you can add commands and script groups via the right mouse button. In GOM Software 2016, the context menus have also improved. If you right-click on point 1, for example, you can see a menu with specific commands. The same menu is available if you use the Sub-Explorer. If you click on a full field element, you can see that you can additionally select on or through surface. By right-clicking the background, you have the same options available as in the 3D toolbar. Now, let us continue with the user interface for visually impaired. Since V8 SR1, the user interface has less contrast. Therefore, the software can be difficult to handle for visual impaired users. Hence, we dealt with the corresponding ISO norm. The results are 2 new additional themes in GOM Software 2016. I will present the improvements live in the software now. For changing the user interface, just go to Edit, Application Settings, Preferences. Now you can switch between the 3 different themes. The default theme is active at the moment. The theme High Contrast is useful for users who have problems to recognize contrasts. If I apply this theme, you can see that all lines are bold now to easily distinguish between different areas of the user interface. Dashed lines help to see the location of the mouse better. The theme Low Luminance is helpful for users whose eyes are getting tired if they look concentrated on a bright screen. Therefore, the background is kept in dark gray. Selections are in red, and there are also dashed lines to accentuate your mouse location. This theme is also helpful for working in dark environments. As always, we appreciate your feedback regarding the new themes. Coming from the graphical user interface, we will now talk about the new CAD Converter. There is a new CAD Converter in GOM Software 2016. It replaces the old CAD Converter of GOM Software version 8 and earlier. In comparison to the old CAD Converter, you can additionally import Autodesk Inventor, CATIA 3D XML, and CATIA R26 files. You can also import PMI from Pro-E Creo Parametric. There is a new knowledge base article in our GOM service area, which provides more information regarding the supported file formats. In GOM Software 2016, the import of MBD information which come with the CAD has been extended. MBD is an abbreviation for Model-Based Definition. It is possible to include all requirements of a drawing in a CAD file, for example, scalar dimensions or GD&T inspections. Therefore, you don't necessarily need a 2D drawing any longer. In GOM Software 2016, the import of common datum systems is now possible. Furthermore, you can import datum systems with material requirements, for example MMR. You can import 2 modifiers for GD&T inspections. These modifiers are separate requirements and simultaneous requirements. The import of distances has also been improved. Distances are now constructed semantically correct. This means that either a projected point distance or a 2-point distance is constructed. This depends on the involved types of the geometries. And finally, the software creates placeholders for incomplete datum systems. If, for example, geometries of a datum system are missing in a CAD file, you can construct the needed geometries and just correct the datum system afterwards. I would like to present the extended MBD import live for you. For the demonstration, I will use a CATIA file. I can easily import it via drag and drop. If I select the nominal elements, you can see that besides the cut, there are also some geometrical elements imported. And there are also some dimensions. Therefore, you do not need to construct these elements any longer. There are also some inspection elements, for example, position tolerances and dimensions. You can see that there are also some actual elements like points and dimensions. These elements are constructed via a reference construction. You can see this if I edit the creation parameters of the distance 1. The distance is constructed semantically correct. No further editing is needed here. There are also two datum systems with and without material requirements. There's also an element group. The cylinders 5 and 6 are checked together for their position with the help of an element group. And there are also two tags. I can easily restore a tag scene via drag and drop. This is very helpful for the reporting. All of these elements are included in one CAD file. You can see that a lot of work can be saved by using the extended MBD import. That was the new CAD Converter. Let us continue with the import of volume data. A tomography reconstructs a 3D volume without destructing specimen. Tomography is increasingly used for geometric inspections and shape analysis. In order to perform 3D inspections, the volume data of the tomography needs to be transferred into a surface representation, a mesh for example. There is a direct import filter for volumetric CT data in GOM Software 2016. The software supports many known data formats. The generation of an exact surface representation is easy. And the software detects multiple materials semi-automatically. The import of CT data is also available in the free GOM Inspect. Please have a look at the What's New video, import of CT data in our GOM service area or on YouTube. Let me present the volume data import now. I will switch to GOM Inspect now. I can easily import the volume data via drag and drop. I can choose between an automatic and an user-defined import. I will choose the user-defined import as the object consists of multiple materials. In this moment, the software analyzes the volume data and will show an import dialog. The thumbnail on the left shows cross-sections of the specimen and shows a preview of the look of the imported data. The first material is presented in red, air in black. Using the pressed left mouse button, you can flip through the sectional planes. You can view the contour of your object in this way. You can also change the viewing direction along the axis. There is a histogram which shows the gray value distribution. Peaks indicate multiple materials. The red square marks the first material and the black square marks the background. You can add more materials. The second material is selected automatically and is shown in green. You can change the material selection and see a preview of your changes on the left. Using the button Reset Gray Values, the software automatically estimates the material values. In order to save some time in this webinar, I will skip the import of the CT data. Instead, I open a project with already imported data. In this project, we can see that different materials are displayed as separate surface meshes. You can delete unnecessary areas simply. For example, you can use the patch selection. Just select the patch that you would like to inspect and invert the selection. Then go to Edit and delete the selected area. We will now switch to the inspection part of this webinar. The first topic here is GD&T, and I will talk about GOM Touch Probe evaluation, point-based evaluation, and bonus tolerances. In GOM Software 2016, you can do GD&T inspections on elements measured with GOM Touch Probes. These elements are supported identically to usual fitting elements, which are constructed on a mesh. This means that you can do all GD&T inspections also for touch probe elements. For example, you can work with datum systems and surface profiles. I would like to present the GOM Touch Probe evaluation for you. In this example, you can see a cylinder. It is measured with a GOM Touch Probe. Now I can easily check, for example, the cylindricity via iInspect. Now, if I want to, I can activate the color deviation representation in the properties. In this way, you can see the deviations for each touch point. In GOM Software 2016, you can also inspect fitting elements which are constructed with multiple points according to ISO 1101. As for the GOM Touch Probe evaluation, these elements are supported identically to usual fitting elements, which are constructed on a mesh. In this example, there are already some surface points. I will construct the cylinder with the help of these points. The actual cylinder can easily be constructed via a referenced construction. Now I would like to check the perpendicularity to plane 3. The last new GD&T feature is the bonus tolerance. A bonus tolerance is an additional tolerance which is added to the tolerance of a GD&T inspection. It is used in combination with a material requirement and the derived element. A derived element could, for example, be a cylinder axis. The direct help document, background information about material requirements, includes bonus tolerances to provide you with further information. Now I would like to present this feature for you. First, I will check the cylinder with the help of the independency principle. In this way, I can check the minimum and the maximum local 2-point size. Then I will check the straightness. I set the type of the tolerance zone to circular. The tolerance is set to 0.1 mm in this inspection. If you want to use the bonus tolerances for this inspection, please select the desired material requirement and set the tolerated element to derived element. You can see that the bonus tolerance is added to the tolerance of the straightness check. The bonus tolerance is 0.3 mm in this example, as this is the difference between the actual and the allowed maximum material size. If you want to know more about these functions, just use the direct help. If I scroll down in this article, I can see a link to the article Background information about material requirements. Besides information about MMR, this article includes information about bonus tolerances. The next inspection topic is the surface defect map. Surface defects are difficult to detect with existing inspections. Surface defects have a low scale and are normally smaller than the tolerances of the CAD. The typical global deviation of a sheet metal part to the CAD is about 1 mm. Therefore, small effects like local bumps and dents cannot be visualized in the color plot of a surface comparison. In GOM Software 2016, you can use the Surface Defect Map to visualize and quantify bumps and dents. The function is inspired by the physical grindstone. The function calculates a theoretical surface based on a mesh for more realistic results. You can compare actual and nominal values in order to compensate for the global deviation. I would like to present the surface defect map live for you. In this example, we have an injection molded part. There are stiffness on the inner side, and I want to analyze the influences of the stiffness on the opposite surface side. The surface comparison does not allow to detect the surface defects very well. Therefore, I want to work with a surface defect map. In order to have proper directions available, I will first construct a local coordinate system. Then I again go to the Construct menu, Surface Defect Map. I will briefly explain the parameters for you. The maximum defect size is related to the maximum size of the surface defect, which is about 10 mm in this example. The direction is the inspection direction. I would like to use the local x-axis here. The normal direction should be perpendicular to the surface. Therefore, I choose the local z-axis here. Now I select the desired area. If I set the scaling of this inspection, you can see that the stiffness on the inner side led to defects of up to minus 0.1 mm in this example. There are 2 topics left for this webinar. Next, I will talk about the motivation for checks on curves. In the past, it has proven useful to extract values from surface analysis along sections and curves. In GOM Software 2016, you can extract values of surfaces with deviation values for sections and curves. Some examples are surface comparisons, surface defect maps, and material thicknesses. You can use some filtering options and use the diagram for visualization. In addition, you can do some further inspections on the section or curve. I would like to present the new functionalities live now. In the demonstration, I will use the surface defect map of the previous chapter. I will extract values from this inspection for a single section. Therefore, to start with, I construct the single section. Via iInspect, I can now use values from surface analysis. The value source is the surface defect map. I can choose it with Ctrl and left mouse button. In this moment, the software transfers the values from the surface defect map on the single section. The values can nicely be depicted with the help of the diagram. The diagram and the 3D view correspond with each other. Our last topic is plausibility check. Sometimes users face implausible measurement results for various reasons. Some of these reasons are gaps in measurements, a varying size and form of parts, and inappropriate alignments. It can be difficult to detect implausible results, especially in automated environments. In GOM Software 2016, you can use plausibility checks to avoid implausible measurement results. I would like to explain this feature now. The plausibility check is a new option available for some measuring principles, such as intersection with mesh, project point onto actual, touch point disk, and touch point edge. If you activate this option, the first step is the construction of the actual point. Then, the 3D distance between the actual and the nominal point is calculated. The second step is the back projection of the actual point to the CAD. Now the 3D distance between the actual point and the back projected point is computed. These two distances are compared in the third step. If the two distances differ substantially, the actual point is rejected. In this way, the software avoids implausible constructions and measurement results. Let me demonstrate this now. You can see that there are plausible results, for example, in the first few stages for point 1. In the fifth stage, there is an implausible construction of the actual point and a high position deviation. The reason is a hole at the nominal point. You can already avoid this when constructing the actual point. You can also edit existing points and activate the plausibility check afterwards. In this demonstration, I will delete the element and set the measuring principle intersection with mesh again. In the expert parameters, you can see that the plausibility is checked by default. A warning message indicates that the actual point is too far away from the nominal point in the fifth stage. After the recalculation, the actual point is no longer taken into account in order to avoid an implausible construction. Now I will hand over to Marcus again.
Okay, thank you, Tobias, for your presentations. We have almost reached the end of the webinar. There are also additional information we would like to tell you. You can download a beta version of the GOM Software 2016 already. And as you may know, the Open Beta program gives you the opportunity to try out new functions and enhancements without affecting your daily work. Please find more information and the software packages under support.gom.com, download software, overview, GOM Software 2016. The final release is planned at the beginning of July 2016. As mentioned at the beginning, this webinar was recorded. You will find the video for download in the support area and also on the GOM Metrology YouTube channel. In addition, as Tobias has mentioned, we have produced video tutorials for new functions, which are also available on YouTube and in the support area for download. You can also find a list of new features in the direct help, as Tobias has showed you for GD&T, and these information also contain links to the video tutorials to the new functions. The next webinar in our series is the virtual measuring room and will take place on the 1st of June. And this was the webinar What's New GOM Software 2016 3D Metrology. We will stay online for a while to answer any further questions in the Q&A section. Thank you very much for your attention. We hope you enjoyed it and have a nice day and auf Wiedersehen.